let's start doing some calculations with tangent ratio. We set it up in the last podcast, but lo and behold, look at this again. I just want to do a fast action review. Remember, we want to use our eyeballs method, okay? We want to use the eyeballs method because that's the easiest way to label a triangle. So here we go. There's our 90 degrees. Look, he's all sad because he's saying, what is all the hype about? The next thing is find out which one's your reference angle. And your reference angle in this question is indicated by that little half slice that you see right here. So I like to put a circle around it. That makes it stand out a little bit more. Don't forget your eyeballs. There's your eyeballs, and of course, it stares at the opposite. And then lo and behold, once you've labeled the hypotenuse, once you label the opposite, that's gotta be the adjacent, and it's done. There's your labeling. Okay, so your tangent ratio, your tangent of A is a ratio of the length of the opposite side to the length of the adjacent side. What does that mean? Very, very simple. It says this divided by this gives you a number which is related to what the angle is. That's all that it means. It doesn't mean anything more than that. Okay, and you can use that to determine the angle eventually, which we'll do on the next podcast. Or eventually, if you're given the angle, you could use that to figure out a whole bunch of stuff about this triangle. Now, one of the things I gave you in the last podcast was a lovely little acronym that says this, TOA, or I like to pronounce it as TOA, okay? All this really means is that your tangent is opposite over adjacent. It allows you to remember this. So let's go. Tan of the angle, whatever the angle is, and in this case it's angle A, is opposite over the adjacent. And I know what you're saying. Well, what about the hypotenuse here? Well, in tangent, we don't really need the hypotenuse. Yes, we will eventually go back to the hypotenuse, but not for tangent, not at this point. All right, so let's go on here and let's see what we can do in terms of setting this question up. Now, read the question. It says write the tangent ratio. Easy peasy, right? Well, let's first off start with tan A. There in tan A, there's our reference angle. That's the one you circle. So if you circle that, ta-da-da, now we label the triangle. So even before we write anything out, we always, always, always label the triangle. So let's do that right now. There's my eyeballs, and of course, oh, poor old hypotenuse, still sad. Yup, what is all the hype about? He's saying, well, the hype about this is this. You put your eyeballs on your reference angle, you are staring opposite, okay, to the opposite side of the triangle, if you like, okay? So now opposite's labeled, hypotenuse is labeled, and lo and behold, there's our adjacent. So if we're wanting to write out TOA, opposite over adjacent for tangent, now we can. Tan of A is opposite, which is 12, over adjacent, which is 16. Now, you should actually reduce this down because eventually you're going to start doing a calculation with this, and the instant you put it into the calculator, it reduces it anyway. So let's look at the simplest form of this. Divide that by 4, divide that by 4. Those are two numbers that can go into both the top and the bottom. That's giving you 3 over here over 4. So the tan of A technically is 3/4. Okay, beautiful. Now that's good to go. Now, I want to do the second one, which is the tan of B. So you know what I'm going to do is I'm going to erase a bunch of stuff here. I'm going to leave this idea of my tan of A being 3/4 because I want to go back to that in a second. I'm going to clean up my beautiful triangle here as well. And now I'm going to do the exact same thing this time for tan B. Notice how I circled B. Guess what? I'm going to go over here and circle B as well. Well, there's my poor old hypotenuse, which hasn't changed. That was hypotenuse before, opposite of the 90 degree, and it's hypotenuse now. Okay? But look what happens here. If you put the eyeballs on B, check out what happens. This is now opposite. This is now adjacent. Aha! So it changes depending on what the reference angle is. Okay, that's excruciatingly important. That's one of the reasons why I'm making such a big deal about labeling this. So let's start looking over here. Let's figure out tan B. Well, don't forget, tan is still TOA, which is opposite over adjacent. There it is. So tan of B opposite is now 16. Adjacent is now 12. And check this out when you reduce this. When you reduce this, it becomes 4 over 3. So check this out. This is the cool part. Look at how these guys compare now. Tan of A, where this was opposite and this was adjacent, means that you've got 12 over 16, 12 over 16, which reduces down to 3/4, and this one, which was our B, where this is our opposite and that's our adjacent, notice how it's 16 over 12, it's reversed. So that's why labeling is so important, because if you don't label it, your fractions are reversed, and oh boy, then we're opening up an ugly can of worms.